St. Hilda's Primary School, Primary 5, Term 2 Weighted Assessment 1, 2025. Okay, for this practice paper, we have actually two papers, paper 1 and paper 2. So in this case, for paper 1, there's calculators are not allowed. Okay, so we start with question 1. What's the value of 70 plus 7 over 10 plus 7 over 100? So in this case, first we need to convert the fractions into decimals. So we have a 7 over 10. If you want to convert to decimal, you take 7 divided by 10. So in this case, 7 divided by 10 will give me a 0.7. Then we are given also another fraction, which is 7 over 100. Once again, to convert from from fraction into decimals, you take the numerator divided by the denominator. So in this case, 7 divided by 100, if you do your long division, you get 0.07. So in this case, the value of everything add up together is just 70 plus 0.7 plus 0.07, which in this case will give me 70.77, which is option 2 in this case. Okay, now we move on to question 2. Find the product of 3 over 8 and 1 over 4. So product means times. So in this case, it's 3 over 8 times 1 over 4. So if you look at these fractions closely, you realize that the numerator of one fraction cannot cancel with the denominator of the other fraction. So in this case, we can just take the numerator times numerator and denominator times denominator. So what you have in the numerator is a 3 times 1, which is a 3, and what you have in the denominator is a 8 times 4, which is a 32. So in this case, your answer will be option 4. Okay, so next for question 3, a solid cuboid of height 5 centimeters has a square base of height 3 centimeters. So for this, it is a square base of side 3 centimeters. So in this case, the base of your cuboid is 3 centimeters by 3 centimeters. So to find the volume, we take the length times breadth times height. So in this case, the length of my cuboid is 3, and then the breadth of my cuboid is also 3 because it's a square base, and then my height is 5. So it's 3 times 3 times 5. So 3 times 3 is 9, and then 9 times 5 is 45. So the answer is option 3, 45 cm cube. Okay, question 4. The figure below shows triangle ABD. When the base is AD, so I'm going to highlight the base of the triangle, which is AD. What is the height of triangle ABD? So in this case, if you want to find the area of a triangle, you need to take half times the base times your perpendicular height. So in this case, your base is AD. It means that your height must be perpendicular to the base, which means it must be 90 degrees to the base. So if you look at this diagram carefully, the height that is 90 degrees to your base would be this line BC here. So your answer will be option 3. Okay, next for question 5. Look at the figure below. Find the area of the shaded triangle. So once again, to find the area of a triangle, we must take half times base times height. And in this case, the base must be one side of the triangle, and your height must be perpendicular to the base. So if you look at the diagram carefully, you realize that your base should be this 10 centimeters here, and your height will be this portion here, which is 8 cm. And this height here, this 8 cm, is perpendicular to your base of 10 cm. So to find the area of the shaded triangle, just half times your base, which is 10 cm, times your height, which is 8 cm, which equals to half times 80 in this case. 10 times 8 is 80. And then half of 80 is 40. So your answer will be option 2, 40 cm squared for the area of the shaded triangle. Okay. Next, the solid figure below is made up of 1 cm cube. Find the volume of the solid. So we look at the solid here, it's like actually an odd shaped object, and we probably cannot find the volume of this odd shaped solid. Okay, so we are given that the cubes are actually 1 cm cube. So we are able to find the volume of one cube, right? In this case, which is just because it's a cube. So a cube means all sides have the length and the breadth and the height is the same. So in this case, to find the volume of one cube, it's just 1 times 1 times 1, which is 1 cm cube. So we know 1 cube is 1 cm cube. And then we are able to count the number of cubes in this solid. So if we're able to count the number of cubes in this solid, we can just multiply by the volume of 1 cube to give me the total volume of the solid. So in this case, we proceed to count the number of cubes in this solid. So first we start off with the tallest stack, which in this case is the one at the back here. So there is actually 1, 2, 3, 4. So this is the tallest stack with 4. And then we count the next tallest stack, which is the one with 3. So in this case, you'll realize that the one at the back as well is 1, 2, 3. So this is 3. And then we count the stack that has 2 cubes. So in this case, the one in front here has 2. Here is 2. Here is 2 as well. And then we count the number of 1 cubes, which is just here 1. The one behind here 1, 2, 3, and 4. So then we can proceed to add up the total number of cubes, which in this case, there is 1 stack of 4 cubes, 1 stack of 3 cubes. Okay, we have 3 stacks of 2 cubes, which is 2 times 3, plus 4 stacks of 1 cube, which is 1 times 4. So in this case, you give us a 4 plus 3 plus 6 plus 4, which in this case, if you add them up, will give you 17, which is your option 4 in this case, for 17 cm cubes for this volume of this solid. Okay, now I'll move on to question 7. So Jimmy had 60 marbles. He gave away 2/3 of his marbles to 5 friends. Each friend received the same number of marbles. How many marbles did each friend get? So Jimmy had 60 marbles. He gave 2/3 of the marbles away. So how much did he give away? Will just be the fraction he gave away, which is 2/3, multiplied by his total, which is 60 in this case. So we have a fraction multiplied by a whole number. So in this case, your denominator of your fraction and your whole number you can cancel, right? Since 60 is a multiple of 3, we can cancel. So 3 becomes 1, and then 60 becomes 20. So in this case, what we have is a 2 over 1 times 20, which is 2 times 20, which is 40 in this case. So he gave 40 to 5 of his friends. So to find out each friend receive how much would just be how much you gave away, which is 40, divide by your number of friends, which is 5. So 40 divided by 5 will give me 8. In this case, your answer will be option 1. Okay, the figure below is made up of a square and a triangle with 2 equal sides. Find the length, the length of the square is 4 centimeters. What is the area of the total figure? Okay, so in this case, we look at our diagram. It's given to us that the side of the square is 4 centimeters, and then it is labeled with the strokes. So I'm just going to label the rest of the diagram with the relevant dimension. So if this will be 4 cm, this will be 4 cm, this will be 4 cm. And you look at your triangle, it also has the same stroke, right? So it means that this side is also 4 cm and this side is also 4 cm. So we want to find the total area of the figure. So we look at our square first. So the area of my square will be just side times side, which is 4 times 4 to give me 60. And then the area of my triangle in this case, since you know that this side here and this side here is the same length. So it means that this is like kind of like a right angle isosceles triangle. So here is the isosceles triangle. So it means it's a right angle there. So to find the area of this triangle would be just taking half times 4 times 4, which in this case is 8. Then the total area will be taking the area of the square, which is 16, plus the area of the triangle, which is 8, which adds up to 24 cm squared, which is option 3 in this case. Okay, we come to the end of booklet A. We'll move on to booklet B. So in this case, find the value of 3 divided by 7. So round your answer to 2 decimal place. So whenever you see this to round your answer to 2 decimal place. So this means to do your long division until 3 decimal place. So in this case, we have a 3 divided by 7. Okay, so you realize that 3 cannot be divided by 7. So what you have on top is a 0, and then 0 times 7 is 0. So 3 minus 0 will be 3. Okay, then you put the decimal place, the next 0, then you bring down the next 0, which in this case is 0, it will be 0 here. So 30 divided by 7 will give you 4, and then 7 times 4 is 28. So 30 minus 28 will give you 2. Then you put the next 0, you bring it down. So 20 divided by 7 is 2. So 2 times 7 is 14. Or 20 minus 14 gives me 6. Okay, then I put the next 0. I'll bring the next 0 down, which in this case, we'll make it 60. So in this case, 60 divided by 7 is 8. So 8 times 7 is 56. And then the remainder will be 4. Okay, so you can stop here already because it's already my long division until 3 decimal place. So in this case, we have our decimal, which is 0.428, and then we round to 2 decimal place. So we look at the third decimal place, and then since it's greater than 5, we will round up, and then it means this will be round up to become 0.43. So the answer is 0.43. Okay, question 10. In a class, 3 of the students are girls and the remaining are boys. 2/5 of the boys wear spectacle. What fraction of the boys are boys who do not wear spectacle? So we know that 3 of the students are girls and the remaining are boys. So we can find the fraction of boys. Okay, which in this case, your class is 1 whole minus the fraction which are girls, which is 3/8. So 1 whole minus 3/8 will give me 5/8. And in this case, we know the fraction of boys who wear specs. So boys who wear specs, in this case, it's 2/5. And we want to find the fraction of students who are boys who do not wear spectacles. So in this case, to find the boys who do not wear specs, will be taking 1 whole, which is the number of boys, the boys, minus 2/5 of the boys who wear specs. So in this case, 1 whole minus 2/5 will give me 3/5. So we know that 3/5 of the boys wear specs. So in this case, since we want to find the fraction of boys who do not wear specs, okay? In this case, we want to find the fraction of boys who do not wear specs. So we take our fraction of boys, which is 5/8, multiplied by the boys that wear specs, which is 3/5. So in this case, we got a fraction multiplied by a fraction. So the numerator can cancel, the numerator of one fraction can cancel with the denominator of the other fraction. So in this case, 5 and 5 can cancel to become 1 and 1. So in the end, we have a 1 times 3 over 8 times 1, which is 3/8. And that will be your answer for this question, 3/8. Okay, now I'll move on to the next question. John glued 9 unit cubes together to form the solid short. Okay, so for part A, we want to draw the top view in the grid below. So you remember you want to draw the top view, right? So whenever you want to draw the top view, you must look at the top view from the front view. So in this case, if you look from the front view, you look at the top view from the front view, you realize that there is actually, you'll see this portion, this box here and this box here. So I'll draw that first. Okay, we have 2 boxes here. So I'm just going to draw the 2 boxes here. Okay, so we'll see these 2 boxes here. Okay, next, if you look closely, you will see this box here and this box here. So I'm going to draw it out as well. This box here and this box here. Okay, lastly, if you look carefully, you realize there's one more box behind here, which is above this box. So I'm just going to draw it out in the diagram. It will look like this. Okay, it will look like this. So you just draw it out and then this will be your answer for part A. Okay, so for part B, John glued more unit cubes to the above solid to form a big cube. What was the least number of unit cubes that John added to form the cube? So in this case, least number of unit cubes, right? Means you want your cubes, you want the cube to be as small, or you want to form the smallest cube possible. So in this case, you look at your figure. Okay, I'm going to erase all these markings first. So you're going to look at your figure. So you figure out what is the dimension of the solid that you already have. So if you look carefully, you realize that from the front view, you realize that you have actually 1, 2, 3, right? 3 cubes along the length. And then if you look at your breadth carefully, you realize you have 1, 2, 3 cubes along the breadth. And then if you were to look at your height carefully, you realize that you have 1, 2, 3 cubes along the height. So in this case, the smallest cube that I can form in this case would be a 3 times 3 times 3 cube, which is 27 cubes in total. So since we know that currently we only have 9 unit cubes, and then in order to form the smallest cube, we need to have 27 cubes. So in this case, how many more cubes must John add? In this case, would be just 27 cubes minus how many cubes you already have, which is 9. So 27 minus 9, this will give me 18 cubes. So the answer for part B will be 18 cubes. Okay, I'll move on to question 12. A tank contains 14 liters, 70 milliliters of water. And we know that Susan pours 3 bottles of water, each containing 500 milliliters of water into the tank without spilling. So what is the volume of water in the tank in the end? Give your answer in milliliters. So you look at the tank, the volume of water in the tank now, which is 14 liters and 70 milliliters. So since we need to give our answer in milliliters, we want to convert everything into milliliters. So in this case, we know 1 liters equals to 1000 milliliters. So we can actually convert 14 liters and 70 milliliters all into milliliters. So in this case, 14 liters, 70 milliliters will give me 14,070 milliliters. So you know that she poured in 3 bottles of water, each containing 500 milliliters of water into the tank. So the volume of water that you added, which is the 3 bottles, will be 3 times 500 milliliters, which is 1,500 milliliters. So to find the volume of the tank in the end will be just the volume of water at first, which is 14,070 milliliters, plus the 1,500 milliliters that you'll be adding in. So in this case, you will get 15,570 milliliters as your answer. 15,570 milliliters for question 12. Okay, for question 13, a shaded triangle is drawn inside 5 identical squares, each of side 12 centimeters. Find the area of the shaded triangle. So we want to find the area of this shaded triangle. Okay, so first we know that the side of the square is 12 cm by 12 cm. So I'm just going to label the relevant dimensions. Okay, 12 cm by 12 cm is for 1 square. So to find the area of the shaded triangle, so in this case, you must remember your formula for area of triangle, which is half times base times height. And then in this case, your base must be a side of the triangle. Okay, so in this case, if you look carefully, right, you realize that the only side of the triangle that you be able to find the length of is actually this base here, which happens to be 12 centimeters, is the side of this 1 square. Okay, and then since the height must be perpendicular to the base, so in this case, this portion here will be your height, right? Because this portion is perpendicular to your base. So the height, which is in purple, represents actually two sides of 2 square, right? So it's 12 and 12. So in this case, to find the height of your triangle will be to take 2 times 12, which is 24 centimeters. Then to find your area of your shaded, we'll be taking half times your base, which is 12, times your height, which is 24. So in this case, we know half of 12, which is 6. So 6 times 24. Okay, then you can do your column working 24 times 6. So you get 80, sorry, not 84. 6 times 2, which is 12, then 12 plus 2, which is 14. So 144. Okay, so it's 144. So your answer for this question will be 144 cm squared. Okay, we've come to the end of booklet B. Now move on to booklet paper 2. So for this case, paper 2, you can use your calculator. So in this case, we are given that a row of ribbon of length 40 meters is cut into 5 equal pieces, so 5 equal parts. So what is the length of each part in meters? Express your answer as a decimal. So we know the total, which is 14 meters. And then to find each part, we'll take our total, divide by the number of parts, which is 5. So 14 divided by 5, if you press your calculator, you get 2.8 meters. So that is the length of each part, which is 2.8 meters. Okay, question 2. A rectangular container is partially filled with 1 cm cubes as shown below. So what is the volume of the container that is not filled with cubes? Okay, so firstly, once again, we do not know the volume of this container yet. Okay, but we are able to find it. Okay, so in this case, we know it is filled with 1 cm cubes. Okay, so can we figure out the dimension of this container? So in this case, to figure out the dimension of this container, we count how many cubes are along the length, along the breadth, and along the height. So in this case, to find how many cubes are along the length, you can count, which is 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 cubes along the length. So you have 8 cubes, which is 8 cm along the length. Then next you count how many cubes are along the breadth, which is 1, 2, 3, 4, 5. So we have 5 cubes along the breadth. And then we count our height, which in this case is just this 1, 2, 3. 3 cubes along the height. So we have figured out the dimension of our container. So next, in order to find the volume of the container that is not filled with cubes, right? In this case, we can find the number of cubes there is actually inside the container. So in this case, count the number of cubes that's inside the container. So we look at each stack. We know that each stack contains 3 cubes each. 3, 3, 3, 3, 3. All the way around, there's 3 cubes. So to find the total number of cubes, we just count how many trees we have, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 trees, which in this case would be your number of cubes, which is 12 times of 3, which is 36. So we know there's 36 cubes inside. And then to find the volume of my container, since I already figured out the dimension earlier, which is 8 times 5 times 3, which is 120. And then to find the volume of container that is not filled with cubes. So the volume of container not filled, in this case, would be just taking your volume of your container, which is 120, minus the number of cubes, which in this case is 36. So this will give you 84. So your answer will be 84 cm cube. Okay, for question 3, in the figure below, A, B, C, D, so AE equals to BE equals to DE, which equals to 3 centimeters, and EC equals to 5 centimeters. Find the area of the figure. So this AE equals to BE equals to DE is equals to 3 centimeters. It's marked out with the stroke in the diagram. And we're given EC is 5 centimeters. So if you look closely, there is actually a triangle on top and a triangle below. Okay, and in this case, the triangle on top and the triangle below all share the same base, which is this line BD here. So we can find the length of BD, which in this case is just, this is 3, so 2 times 3, which is 6 centimeters. So that is my base. So to find the area of the top triangle, is your base times perpendicular height, which in this case, your height would be this 3 centimeters here. So triangle, the top triangle, which is triangle ABD, will be half times 6 times 3, which will give me 9 cm squared. And then to find my bottom triangle, which is triangle BCD, it is, your base is also the BD, and your height will be this EC portion, which is 5 centimeters. So half times your base, which is 6, times your height, which is 5. So this will give you 15 squared centimeters. So to find the whole figure, total area will be just 15 plus 9, which is 24 cm squared. That will be your answer, 24 cm squared. Okay. Next, question 4. 4 out of 9 of the pies that Mrs. Tay baked were apple pies, and the rest were pineapple pies. So she gave half of the apple pies to her neighbor and 3/5 of the pineapple pies to her children. And then in the end, she had 60 pies left. So how many pies did she bake? So in this case, we are able to use like a part-home model to kind of represent how many pies were apple pies and how many pies were pineapple pies. So in this case, 4 over 9 were apple pies. So I can draw my part-home model. Okay, I will cut into 9 parts. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 parts in total. And then we know that 4 out of 9 is apple pies. So I'm going to label this as apple pies. And then the rest were pineapple pies. So what we have in the remainder here, the remaining boxes behind, it is pineapple pies. So we know she gave half of the apple pies, right? So in this case, half of the apple pies. So your apple pies is 4 units. And then you gave half of it away. So it means you gave half of 4 units away, which is 2 units. So I'm going to shade 2 units away from the apple pie, which is what you gave away. Okay? And then you also know that, she gave 3/5 of the pineapple pies to her children. So you look at your pineapples, you realize you have 1, 2, 3, 4, 5 units. So you gave 3 units away to the children, right? So you're gonna shade away that you gave it away again. This is how much you gave away. And then if you look closely, what you have left, which is the unshaded parts, right, are basically those that you are left with. And in this case, it tells us that we had 60 pies left. So you look at the number of parts left, happens to be 1, 2, 3, 4, 4 parts. So in this case, 4 units is equals to how much we're left, which is 60. And then in this case, since we know 4 units is 60, you can find 1 unit, which is 60 divided by 4 to give you 15. So how many pies did she bake? So you know in total we have 9 units or 9 parts. So 9 units equals to 9 times of 15, which in this case will give me 135 as my answer for question 4. Okay, let's move on. Question 5. The figure below, not drawn to scale, shows a rectangular container. For part A, find what is the volume of the container. Give your answer in liters and milliliters. Okay, so we're given the dimension of the container, which is the length is 25, the breadth is 8 centimeters, and the height is 12 centimeters. So we have to find the volume of the container. In this case, to find the volume of container, we will take our length times breadth times height, which is 25 times 8 times 12. Okay, so if you do this, if you enter in your calculator, you get 2,400 cm cube. Okay, in this case, the question says to give your answer in liters and milliliters. And what we have here is in terms of cm cube. So you must remember that for the conversion from cm cube to milliliter, 1 cm cube equals to 1 milliliter. So in this case, 2,400 cm cube, we can convert into milliliter. It will be 2,400 milliliters as well. Okay, but since the answer wants us to give it in liters and milliliters, we have to convert 2,400 milliliters into liters and milliliters. So we also know that from milliliters to liters is 1,000 milliliters is equals to 1 liter. So we can convert 2,400 milliliters into liters. It will be 2 liters and 400 milliliters as your answer for part A. Okay, part B. The container has 1 liter and 43 milliliters of water in it. How much more water must be poured into the container so that the container is 3/4 full? Give your answer in cubic centimeters. So now the container contains 1 liters and 43 milliliters of water in it. So what we're going to do first is convert all of these into milliliters. So 1 liter and 43 milliliter. If you were to convert to all into milliliters, it will be, so 1 liter is 1,000. So it will be 1 liter is 1,000 milliliter. So in this case, it will be 1,043 milliliters. So next, we need to find how much more water must be poured in so that the container is 3/4 full. So this is same as finding the volume of the container when the container is 3/4 full. So in order to find 3/4 of the container, we will take 3/4 multiplied by the volume of the container, which is what we found in part A, 2,400. Okay, so you can press this in your calculator, or if you can see that actually the fraction, the denominator of the fraction and the whole number you can cancel. So in this case, if you were to do the cancellation, 4 will become 1, and then since 2,400 is a multiple of 4, this will be 600, and you'll get a 3 over 1 times 600, which gives you 1,800 milliliters. So now currently you only have 1,043 milliliters of water in the container, and you want to pour in more water to make it 3/4 full, which is 1,800 milliliter. So to find how much more water you need to pour in, you take what you have at the end, which is 1,800, minus what you have initially, which is 1,043. So 1,800 and minus 1,043 in this case will give you 757. Okay. And in this case, the units that you calculated is all in milliliters. And the question states to give your answer in cubic centimeters. So it means cm cube. So in this case, if you remember the conversion from part A earlier, 1 cm cube equals to 1 milliliter. So in this case, for milliliter to cm cube, we can just convert it directly, which will be 757 cm cube. Okay, that will be for part B, 757 cm cube. Okay, next I'll move on to question 6. The figure below is made up of a square and a rectangle. Find the area of the shaded part of the figure. Okay, so in this question, we are given there's a square with the side of 30 centimeters, and we're given a big rectangle with the length of 70 centimeters. Okay, and then we want to find the area of the shaded part. So if you look at your shaded part, you realize that it's actually an odd shape figure. Okay, so there probably isn't any direct way that you can find this shaded part. So in this case, I want you to be able to visualize, okay, if I were to extend the whole figure to form a big rectangle like this, and then you can see what surrounds the shaded area is actually made up of shapes that you are able to find. So in this case, what is surrounding the shaded part is actually a triangle above. See, there's a triangle here. Okay, I'm going to call this triangle A. Okay, there's a triangle below as well. I'm going to call this triangle B. And lastly, there is a rectangle here, which I'm going to call C. So if you imagine, now we have a big rectangle. Okay, and then if we were to minus the part A, part B, and part C, we would just be left with the shaded part. So that is probably one of the approach that you should try to do. So in this case, now we will just have to figure out the different dimensions that we need. Okay, since we know the side of the square is 30 centimeters, so here will be 30 centimeters, and it means that the breadth of my rectangle C will be 30 centimeters as well. So next, we can go and find the length of the rectangle, which is this portion here. Okay, so in order to find this portion here, we know that this whole length is 70 centimeters. And then in order to find the length of rectangle C, we can just take 70 minus 30 to give me 40 centimeters. So this portion here is 40 centimeters. And then next, what else do we have to find? It's probably this portion here. Okay, which in this case will be the length of the big rectangle now, which is the 80 centimeters. Subtract away the breadth of the rectangle C. So in this case, 80 centimeters minus 30 centimeters, this will give me 50 centimeters. For this portion here, 50 centimeters. So now we have figured out all the relevant dimensions. Then we can proceed to find the areas of the respective triangle and rectangle. So first we find the area of A, okay, which is a triangle. So in this case, if you look closely, this corner here, which is the square, it's a right angle. Okay, this corner here is a right angle. So in order to find the area of this triangle, it's half times my base, which is 30, times my height, which is 80. So for this, you get 1,200. And then next, we find the area of B. So area of B in this case. In this case, this is the corner of the rectangle. So this is the right angle. So to find the area of the triangle is half times my base, which is 50, times my height, which is 70. So this will give me 1,750. Then lastly, we find not lastly, we'll find the area of C now. So area of C is just a rectangle. And then we know the length is 40, the breadth is 30. So it's just 40 times 30, which is 1,200. Okay, so now we found the part A, part B, and part C. So next we find the area of the big rectangle. Area of the big rectangle will be your length is 80, your breadth is 70. So 80 times 70, which gives me 5,600. So in order to find the shaded, which is the triangle, sorry, not the shaded triangle, the shaded part in this case, to find the shaded, we'll just have to take our big rectangle, which is 5,600, subtract away parts A, B, and C, which is 1,200, 1,750, and another 1,200 for part C. So this will give me the answer of 1,450, which is your answer for this question 6. 1,450 cm squared. That is the area of the shaded part. Okay, we have come to the end of the paper. Thank you.